I am Anil Kumar. Welcome to my series on vectors. Let us try to understand how to find shortest distance from a point in R2 on a line. So we have 4 examples here, and I have taken all kinds of lines in vectors which you are familiar with. So the question here is, for each of the following, find the shortest distance from Q 3 minus 2 to each line. So we need to find shortest distance from this point to each line. First equation is in the scalar form 2x minus y plus 3 equals to 0. Then we have x equals to minus 2. C is x minus 2 over 3 equals to y plus 3 over 4. And then we have r equals to minus 3 minus 7 plus t 2 minus 4, where t belongs to real numbers. So that is in vector form. So let's begin with the very first one, which is A. The standard equation given to us is 2x minus y plus 3 equals to 0. And the point given to us is Q 3 minus 2. So we need to find the shortest distance. Now, if you are given an equation in scalar form right there, then you can actually see that the normal is 2n minus 1. And in this particular case, the distance is easy to figure out. You can always, if you have a standard equation, let us say in the form of ax plus by plus c equals to 0, then the distance is, and let's say the point you're talking about is, let's say x0, y0. In that case, the distance will be ax0 plus by0 plus c, right? The absolute value of this, since the distance is always positive, correct, over the magnitude of the normal, which is in this case we'll write a square plus b square. Okay, square root is always positive. So that is a standard formula which you can always apply and find the distance. So in the part A, the value for point Q is 3n minus 2. We'll substitute here and say the distance is absolute value of 2 times 3 minus y is minus 2 plus 3, right? So that is the numerator for us, and in the denominator it is square of 2 square, right, plus minus 1 square square root. Perfect. So that becomes your distance. Now here it is 2 times 3 is 6, 6 plus 2, 8, 8 plus 3, 11, over square root of 4 plus 1, 5. So we get our answer as equal to 11 over square root of 5. Okay, so that is straightforward. Now let us take part B also, which is relatively much simpler. The only thing is you need to visualize what that line is. Then it is 1 minute or less than that to answer, right? So the line given to us now is, let's talk about B, x equals to minus 2. So what is this line x equals to minus 2? We are given a point 3 minus 2. So let us say that is 1, 2, 3 and 1, 2. So that is the point Q given to us, which is 3 minus 2. Now what is this line x equals to minus 2? So x equals to minus 2 will be a vertical line, correct, which I can draw here. That is my line x equals to minus 2. Now from this line, what is the distance? Clearly the distance here is that much. It is parallel to the x-axis, so this is minus 2 from 3 to minus 2. So the distance here is equals to 3 minus of minus 2, which is 5 units, correct? So that is straightforward. The distance is 5 units, correct? So that is how you're going to figure out this answer. So those were the simple ones. Now, slightly tricky ones are part C and D, where we are actually not given the normal, right? So how do we find the distance from a point to these? That is what we are going to see now, one by one. Okay, so here is part C, which is find the shortest distance from Q to this particular line, right? So let's see how to visualize this and work it out. So the line which is given to us has a direction. We can say the direction is 3, 4, right? And it has a point on it, and this point is 2 and minus 3, which is known to us, right, from the equation itself. Now we know the point Q is 3 minus 2, from where we have to find the distance. Now, in the given situation, let us say we have the line which could be represented as something like this. Now, on this line, we are given a point which is 2 minus 3, right? So let's say this is 2 minus 3. Okay. Now, if that is 2 minus 3, right, so, well, 3 minus 2 could be very close to the line, okay, anyway, so that is your point Q. So what we do here is we find the normal from the direction itself. So let's find the normal to the line. Normal to the line will be what? If it is 3 and 4, we can swap this, correct? And change one of the signs. So that becomes the normal to our line L, right? So let's say this is the line L, that becomes the normal. Now the idea is that we will actually find what is the direction between PQ. So let's find the direction PQ. Direction PQ will be what? 3 minus 2 and minus 2 minus 3, minus of minus 3, right? So that gives you 3 minus 2 is 1 and minus 2 minus 3, that means 3 minus 2, that is 1, 1. So that becomes the direction PQ. Now, to find the normal, to find the distance, the shortest distance, what we really do is, so I'm not making the exact value of Q, since that will not give me a lot of space to work with, but let's try to understand. The normal here is given to us as 4 minus 3, right? So let us assume that 4 minus 3 is somewhere here, right? So let's say the point is here, Q. Okay, let's assume that the point Q is here. Okay, now that becomes the normal from Q to the line. This is the normal, right? So what we have done here is that we have connected P with Q. So that is what we have connected. Now, the shortest distance is actually this distance. From Q to, let's say, this point N, this distance is the shortest distance. So what we can do here is, we know we can use dot product. So if I use dot product, then I get this distance Q to N along the normal. So that is the idea. So now we can write the distance of this as the dot product between PQ and the normal, right, divided by the magnitude of the normal, right, 4 square plus minus 3 square. So that is the formula which we use to find the distance from any point when we are given a vector equation or equation parametric form. Now, let's see. We know PQ is 1, 1. So absolute value, since distance is always positive, right, dot, the normal is 4 minus 3 over 4 square plus 3 square, which is 16, plus 9, which is 25. Okay, now let's do this. So get 4, and then we have minus 3 divided by 5, right? 25 square root, and that gives you 1 over 5. So indeed that was a very close point, right? So we get the distance as 1 over 5. So I hope this method is clear to you. So the steps involved are that just take a direction vector from Q to a point on the line, and then use dot product with the normal. That will give you the component along the direction of the normal. When you divide with the magnitude of the normal, then you get the exact distance. Perfect. So the distance here is 1 over 5 units. So let's take the last example now, where we have a vector equation. So steps are exactly the same. So step number 1 is write down the direction of the line. So the direction of the line is given to us as 2 minus 4. Now, so the normal will be 4, 2. Well, you can also write this in simpler form, which is 2, 1, right? Since it is just the direction, right? Now, then the second part is that you have to find what point is given to us. The point given to us is minus 3 minus 7. We know Q, which is 3 minus 2. Let us find the direction or the slope between P and Q, right? Let's find this direction. So that will be 3 minus 3 minus 2 minus 7, correct? So that gives you 6, and this is 5. Okay, so that is your direction along PQ, and we know this is the normal. So now the distance is what? So distance is a positive quantity, which is dot product of MPQ with the normal divided by the magnitude of the normal, correct? So let's place the values. We have to find this is the dot product, okay. So dot product of 6, 5 with the normal, which is 2, 1, divided by its magnitude, which is 2 square plus 1 square. Absolute value. So the answer here is 6 times 2 is 12 plus 5 times 1 over 4 plus 1, 5 square root. Correct? So that gives you 17 over square root 5 as your answer. So that is how you can actually find distance between a point and the line. So I hope the steps are absolutely clear. I'll provide you a link where we will see how to find the shortest distance from a point to a line in R3, and also how do we find a point on the line which is closest to the outside point in R2 as well as in R3. So that should help you to get good command on this particular topic. The question here is, find the shortest distance between the point P, 2 minus 10, and the line R, minus 2 minus 1, plus S minus 4, 3, where S belongs to real numbers. So let's try to understand the concept here. Let us say the given line is something like this. So that's the line given to us. And let us consider that there is a point which is somewhere here. Now, the idea here is to find the shortest distance. Well, shortest distance will definitely be something which is perpendicular, right? So that is going to be the shortest distance. So we need to find a point Q right there, and this is the point P which is given to us. On this particular line, let's call this line L1, given by this equation. Now, how do we find this point Q? That is one question. However, here we have to find the shortest distance. So what actually we can do is we could take any point on this line, right? let's take any point on this line. Let's say that is another point on the line. We call this point as P1. A general point on this line. Now, the shortest distance PQ is what? From here, you can see that PQ is scalar projection of PP1, right? So the shortest distance becomes the scalar projection, right? So if I use this length here and I want to find what this is, then P to Q will be basically equal to, let me write down here, P to Q will be basically equal to PP1, right, times cos of theta. Correct? So, as you can see from here, the shortest distance PQ is a scalar projection of the distance between these 2 points. So if I take any general point, I can use the concepts of scalar projection and get the result. Perfect? So that is what we are going to do. So what we will do here is that we already know that point P is given to us as 20 minus 10. The line equation is given to us as R equals to minus 2 minus 1 and S is equals to minus 4, 3. Now, to find the scalar projection, we need to find the direction of PQ also. So what is the direction of PQ, which is normal to the line, right? So we understand that PQ is normal to the line. Correct? Now from the given equation, direction of line is given to us as minus 4, 3. So the normal will be what? We can flip this and change one of the sign. So that becomes the normal. Perfect. So in R2, it is very easy to find the normal. Once we get the normal, in that case, we can actually find the direction of PP1 and do dot product with this normal and get the projection. Correct? So let us find the direction for P to P1. What is that direction? So we know P is 20 minus 10. We also know a point here, minus 2 minus 1. So let's assume this point is minus 2 minus 1. Is it okay? So in that case, the direction from P to P1 is going to be what? It is going to be 20 minus minus 2, so that becomes 2, right? And minus 10 minus this, that becomes minus 9, which basically will be 22 minus 9. Correct? So the shortest distance PQ can now be written as equal to the dot product of this normal with the direction of PP1, right, with the normal divided by the magnitude of the normal. Correct? So that is what scalar projection is. So let's calculate this value. So we know PP1 is 22 minus 9 dot, this is 3, 4, and magnitude will be square root of 3 square plus 4 square. Clear? And always this value is going to be the absolute value. Correct? So we'll take positive value. So this is always a positive value. Correct? Now let us calculate. What do we get? So 22 and 3 gives us 66 minus 36. That is a dot product in the numerator, which happens to be positive. Square root of this, is 5. So what we get here? So that is 0. 30 divided by 6 minus 3 is 30 divided by 5, and 30 divided by 5 is the value 6. So we get the answer here as 6. So the shortest distance is 6 units. So I hope the formula which we have used, rather derived, is absolutely clear. Now there is a standard formula also which you could use, provided you convert this into Cartesian equation, right? And in that case, you could use the formula that distance is equal to the absolute value of ax1 plus by1 plus c divided by the square root of a square plus b square. Right. You could use this formula also to find the shortest distance. So what I'd like you to do here is convert this to the scalar form in this form, use this point and find the answer, and then compare with the result given. Let me extend this and show you how we can actually find the distance using alternate method, right? So that'd be interesting. So let us extend this to find distance using alternate method. So I'll take it on a new page. So again, the same question here. Find the shortest distance between the point P, 20 minus 10, and the given line R. R is minus 2 minus 1 plus S times minus 4, 3, where S belongs to real numbers. So from the given equation, we could actually write x value as minus 2 minus 4s, the y value as minus 1 plus 3s, correct? So we kind of get the parametric form from here. So if I rearrange the x value, see what the s could be here. So if I rearrange this, what do I get? I get x plus 2, right, equals to minus 4 s, and from here I could actually get s as equal to x plus 2 over minus 4. Did you see that? So these are kind of critical steps to convert a vector equation into a parametric equation. Do you see? And then a symmetric equation, correct? Now we'll do the similar steps with the y. So with this equation, we'll do y plus 1 equals to 3 times s, which gives us s as equal to y plus 1 over 3. Now both should be equal, correct? Both should be equal. So we get x plus 2 over minus 4 equals to y plus 1 equals to 3. Now we can cross multiply and then solve, correct? So we equated both these equations. They are both s, right? And from here, we'll just cross multiply. We get 3 times x plus 2 equals to minus 4 times y plus 1. Bringing them all together after opening the brackets, we get, let me rewrite this. Okay, now bring them together. So we get 3x plus 4y plus 6 plus 4 equals to 0. So that gives you the equation 3x plus 4y plus 10 equals to 0, correct? So that becomes your scalar Cartesian equation in R2, right? So we have the equation of our line as what? As 3x plus 4y plus 10 equals to 0. Now we need to find the shortest distance from external point P, which is 20 minus 10. Perfect. So what is this equal to? So that distance is basically equal to the absolute value of ax1 plus by1 plus c over square root of a square plus b square, right? Where a and b are normal, correct? So in our case, what is a and b? That is the normal 3 and 4, right? A and b are these values, the normal to the given line. Perfect. So from here, we can actually calculate the answer. So what we get here is, so a is 3 and x is 20. So we get 3 times 20 plus 4 times minus 10 plus 10, absolute value, divided by square root of 3 square plus 4 square. Correct? So this is equal to what? 60, and this is minus 40, and that is plus 10 over 9 plus 16 square root is 5. So that gives you 60 minus this is 20, 20 plus 10 is 30, 30 over 5, which is same as 6 units. Do you get the idea, right? So we get exactly the same answer, 6 units, and that becomes your alternate method. So I hope you understand and appreciate how these two methods are linked, and also the concept which we use, right? Finding dot product with its scalar projection and then finding the answer. I hope you find it interesting and useful. Now we'll try to use the same concept for R3 also and show you how using both dot product and cross product we could actually find the shortest distance in three-dimensional space. We'll explore how to find the shortest distance from a point in R3 on a line. Now there are two different methods which can be followed. One is using the dot product and the other one is using the cross product. We'll also discuss when to use which method. Let's look into these two questions. Question number 1 here is, determine a point on the line that produces the shortest distance from the point. Find the shortest distance between the point and the line. Well, if that is the question for you, which clearly says that, let us say we have a line here and we are given some external point P, then it says determine a point on the line that produces the shortest distance. That means we have to find a point here which is on the normal of the line, right? So if I'm given a point P, I need to find Q. That is my first part. Correct? So if you follow this method, and of course when you find the point Q, you can find the distance also. So if that is the case which you're trying to solve, then it should be solved using dot product. Clear? So the first example here will be solved using dot product. We need to find a point, and so dot product should be 0 between PQ and the direction M of the given line. Is that clear to you? Now look at the second question. It says, calculate the distance between the point and the line. So when it says calculate the distance, it automatically means shortest distance, right? From a point which is supposed to be external. If it is on the line, you'll get 0 as your answer and the given line. Now if that is the case, you have a choice. You could use dot product, you could use cross product also. Now how do we justify that? It's kind of like this. Let's say again we have a line given to us and we have an external point. Now in that case what we do is that from the external point P, we do not find the point Q, right? We just don't find this point Q. In fact, we pick up a point given to us. So in this case, a point is given to us. So we'll say, well, let's let's think about these 2 points, right? So we are saying we have a point here P0 which is given to us, correct? Now the direction of PP0, right, this direction, right, and this direction have an angle in between, right? This angle, let us say, is alpha. In that case, what is PQ, which is the shortest distance, right? What is PQ? So from here, we can see that this distance D, P to Q, let's call this distance as D, will be equal to the absolute value of PP0 with sine of alpha, correct? Correct? That is the opposite side. But you know the cross product. The cross product is that if I do the cross product between PP0, call this vector PP0, right? Cross product with M, the direction of this line, right? In that case, what do I get? The cross product is magnitude of these two times sine alpha. Correct? So from here rearranging, what do we get? We get PP0 cross product with direction of the line divided by the magnitude of the line actually gives us PP0 sine alpha, which in our case is the shortest distance, PQ, right? So that is what we want to find. That is what PQ is. That is what D is. Is that clear to you? So you can use cross product to find the answer. So we are going to use cross product for our second example. So in this example, we'll use cross product. Is that clear to you? And then we'll see how to apply both these methods to find the shortest distance. Perfect. So let's begin with the solution of the very first one, which is determine a point on the line R, which is 1, 2, minus 1, t 0, 1, 1, t belongs to real number, that produces the shortest distance from the point P. Find the shortest distance, correct? So first step is we'll just find a general point, correct? So from the given equation, we can say what is x equals to? X is 1 plus 0, 1 plus 0t, let me write. Y value is basically equals to 2 and plus t, and the z value, that is a general point, is basically equal to minus 1 plus t. Correct? So that becomes a general point on our line given to us, right? Now we have an external point given to us which is minus 1, 1, 6. Now what is the direction between this general point, which is, we'll call this as P0 for us, right? So now, what is the direction between PP0? So let's find that. So vector PP0 will be what? So from here, we can do this minus this. So what we get here is basically 1 minus 1, which is 2, right? And then we have 2 plus t minus 1, right? 2 plus t minus 1, which is 1 plus t. And then minus 1 plus t minus 6, which gives us minus 6 plus t, correct? So that becomes PP0, correct? Now what is the direction given to us? The direction of the line is given to us as 0, 1, 1. Perfect. Now, for them to be perpendicular, dot product should be 0, right? So for them to be perpendicular, we have PP0 dot M, which we can now multiply, dot product, which is 2 times 0 as 0 plus 1 plus t times 1, which is 1 plus t, plus minus 7 plus t, which is minus 7 plus t, that should be equal to 0. Clear? Now let's simplify this. We get 2t equals 2. We have minus 6 here, right? 1 minus 7 is minus 6. Going to that side becomes plus 6. So that gives you the value of t as 6 divided by 2, which is 3. Perfect. So we know what t is now. So we can find what the point P0 should be, right? So P0 should be, substitute t equals to 3, right? So we'll be at t equals to 3. So let's substitute this value. So we get x value as equals to 1. Y value will be equals to 2 plus 3, which is 5, and the z value is equals to minus 1 plus 3, which is 2. So we get our point P0, right? So we can write P0 as a point which is 1, 5, 2. Correct? So once we get this point 1, 5, 2, we can actually find the distance using the distance formula, right? So what is the distance now? So the distance will be equal to square root of, we know the 2 points, right? The one given to us, P, right? Let me write down here, minus 1, 1, 6, and that is what we found, correct? So this square, 1 minus, that becomes plus 1 whole square, plus 5 minus 1 whole square, plus 2 minus 6 whole square, correct? That's it. So that is square root of 2 square, which is 4. This is 4 square, which is 16, and this is again 4 square, which is 16. So that gives you 20 and 136, which is 6. So 6 units. So we get our answer, which is minimum distance, or the shortest distance, equals to 6 units. Is that clear to you? Correct? So we found both the things. We found the shortest distance, and we also found the point, right? So both the things. And the point was, closest point was 152. Is that clear to you? So that is how we can actually use the dot product concept to find the solution. Correct? Now let's take the second example and see how the cross product concept can be used to find the shortest distance from a point in R3 to the line. Now let us find the shortest distance using the cross product. The question here is, calculate the shortest distance between the point P, 1, 2, minus 1, and the line R, 1, 0, 0, plus T, minus 4, 5, 20, where T belongs to real numbers, right? So when you are using the cross product, then the shortest distance formula D is basically equal to the cross product of this direction times the point P0, right, divided by the magnitude of your direction, correct? So that becomes the formula. Now let's try to see what we are given and how to find the shortest distance. So what we are given here is the point P, which is 1, 2, minus 1, and that is a point given on the line itself. We'll call this as P0, 1, 0, 0, correct? So from here we can find what is P0. So that will be 1 minus 1 is 0, 0 minus 2 will be minus 2, and 0 minus 1 will be 1. Okay? So we get P0. We know the direction M basically is equal to minus 4, 5, 20. So let's find the cross product first. So the cross product will be what? Will be 0 Well, let's write this first. Minus 4, 5, 20. The order doesn't matter here since we are taking the magnitude, right? 0, minus 2, 1. Right. So let me use matrix to find this cross product. So which is ijk minus 4, 5, 20 and 0, minus 2, 1. Okay. So I value 4, 5 times 1 is 5. Minus and minus becomes plus 40 here, minus j. Then minus 4, and that is 0, plus k, which is 8 minus 0. So that basically gives you 45i plus 4j, 8k. Correct. So from here we can calculate the magnitude of the cross product, right? So from here the magnitude of this cross product is equal to square root of 45 square plus 4 square plus 8 square, which is basically equal to, let's calculate. We have square root of 45 square plus 4 square plus 8 square, which is 45.88. Let's write down. Okay. Now, what is the magnitude of, so we got the numerator and we need to find the magnitude of this, or we can just substitute. Let's find. And what is the magnitude of the direction? Which is square root of minus 4 square plus 5 square plus 20 square, correct? Which is basically equal to square root of 16 plus 25 plus 400. 21. So this is basically 21, correct? So now we get both the numerator and the denominator, and so we can now find the distance d, which is basically equal to the magnitude of cross product, right, over the magnitude of direction, so which is for us 45.88 divided by 21. So let's do it. We have 45.88 divided by 21 equals to, in decimals, 2.18. So that becomes our answer for the given question, right? So the minimum distance basically is, let's say, 2.2 units. Correct? So that is how you could actually use the cross product to find the answer. So I hope both the methods are absolutely clear. Feel free to write your comment, share your views, share my videos with your friends. If you have questions, write them in the comments. Thanks for watching and all the best.